In section 5.2, question 2, we're going to continue to fill in the reasons on the proofs that we are asked to solve. So notice in example 2, it says that lines A and lines B are perpendicular. Now, perpendicular, just so that we're all aware, is the symbol. It's kind of like an upside down capital T. Now, line B is the vertical line that goes up and down, and line A is the horizontal line. And we know that we're given that both of those lines come together to be perpendicular. And we're trying to prove that angle 3 and angle 4 are complementary. Now, if we look at this image, angle 3 and angle 4 come together to form that right angle. And we know it's a right angle because we know perpendicular lines are right angles. Now, the reasons that we're given is the definition of a perpendicular line, given, vertical angles are congruent, definition of a right angle, the substitution property, and definition of complementary angles. So the only ones I do want to go over real quick are the definition of perpendicular lines and the definition of right angles, because even though they're very similar, their definitions are different from each other. So let's just look at the sheet that I filled out for you. The definition of a perpendicular line are two lines that form a right angle. Whereas, and that was a typo, so I'm sorry. The definition of a right angle is an angle that measures 90 degrees. So right angles have specific measurement of 90, whereas perpendicular lines, we just know that they're right angles, okay? So if we go back to our sheet, let's go ahead and start filling in the reasons. Statement A says lines A and B are perpendicular. Now, looking at our word bank here, that's going to be the given, okay? Your given is always the first reason up here, and it's always also the first statement on the left. Now, we're given that lines A and B are perpendicular, and step B says angle 1 is a right angle. Well, I know that angle 1 is a right angle because the lines are perpendicular, which is the definition of perpendicular lines. Now notice how I used the symbol here. You could spell out the words, that's fine. It would not be the definition of a right angle because it says nothing about a degree of 90 degrees. Okay, so I know that angle 1 is a right angle because the definition of perpendicular lines. Now, based on that, why can I say that the measure of angle 1 is equal to 90 degrees? Well, now that I know angle 1's a right angle, I can specifically say the degree measurement by the definition of right angle. Okay. From there, it says that angle 1, which is this angle that I marked over here, angle 1 is congruent to angle 3 plus angle 4. So angle 1 is congruent to that pair of angles over there. And based on the choices I have left, I know that those angles are vertical angles, and vertical angles are congruent. So I can say vertical angles are congruent. Now from there, in order to go from D to E, what do you notice is different? Well, the angle 3 is still there, the plus sign is still there, and the angle 4 is there. The only difference is that angle 1 turned into 90 degrees. Now looking at the choices we have left, I got substitution property or definition of complementary angles. What I did in order to go from D to E is I took angle 1, which I knew was 90 degrees, and I substituted it in to the equation itself. So this would be the substitution property. Okay. Whereas the last step says angle 3 and angle 4 are complementary. Now complementary angles, you know, if you just look on our sheet real quick, are two angles that come together to make a right angle, or two angles that come together that form 90 degrees. Well, angle 3 plus angle 4 come together to equal 90 degrees. So this last statement here is going to be the definition of complementary angles.